The kids in 2010 were really lucky because we already saw the first two questions were pretty easy, and it turns out the third one is too. So this problem's dealing with the hiking trail. Elevations of the trail are stored in an array as ints. They're indexed, just like a typical array would be indexed. It's called markers, right? So we just talked a little bit about, always using proper array names or list names. So markers is the name of this array. It just holds plain old ints, so no user-defined class to worry about here. The methods are unrelated, so I don't have to worry about calling part A's method from within part B. Okay, and I'm just going to return true in part A if the difference between the maximum and minimum elevation of a segment of the trail is less than or equal to 10 meters. So gotta find the min, gotta find the max, subtract them. If I get less than or equal to 10, true, false, otherwise. Probably the challenging part here is understanding that this is just a trail segment. It is not the entire trail. Okay, so when we write our code, we have to understand that start is where this begins, end is where it ends, guaranteed that start is less than end, and guaranteed that they're both in bounds. So no flying stuff, no tricks, nothing weird to worry about here. Okay, so I don't have to write any like special cases or anything. I will begin my loop at start. I will end my loop at end. And then in part B is difficult. This time we actually look at the whole trail. Okay, so it's not a segment, entire trail. And it's difficult if there's at least 3 changes of 30 meters or more. And those could be up or down. So absolute value would be advantageous here because, like for example, if I see a downward switch of 40 meters, that's still counted as difficult, but it would be marked as negative 40. So absolute value would help me just work with the magnitude of those changes. Okay, in part A, one trick that we've seen previously with mins and maxes is do not initialize them to 0. Unless you're searching by index. If you're searching by value, which makes sense here because we need the value anyway, don't start at 0. If you put this min at 0, you're never going to find an elevation below that, and you're going to end up with a fictitious min. So what you should do is you should go to the markers array, perhaps at start. I could see going to start or to end, or some combination in the middle of them. And then I'll make a max, and I'll just go ahead and also initialize it to markers start, which you might think, oh, that's risky, but it's not. It's going to work itself out in the end. We're going to figure it out. Okay. And then I'm going to write a loop. This loop is going to, I guess technically you could begin it at start plus 1, but it doesn't really matter. If you wanted to just, or you could even write an easy while loop here too. But yeah, if we're doing a for loop, then maybe you just want to initialize it to begin at start. We want to be inclusive of end. Okay, it was clear on that in the directions. Don't stay less than end. You want to include it. It's not going to go out of bounds. Don't worry. Okay, and we're going to have 2 checks in here. So if I go to markers I, and it turns out that that's less than markers, well, actually, let's just call it min, then that means I have the min wrong. Okay, so I would need to reset my min. And we could use the word else here if we wanted, but it doesn't really matter, I guess. So we'll just ask a second question. If markers I is greater than max, then we got our max wrong. And so in the end of this process, we should be left with the actual min and max elevation from the trail. We want to know if I take max and I subtract min, do I get back a number less than or equal to 10? And they were clear. Hey, so we've seen that before. Okay, don't lose a full point on your test because you forget to put an equals there. Or if you put one when you don't want it. This one was clear though. It wants to allow 10 as a potential value. All right, difficult. This is a counter method. Are we going to see at least 3 difficult switches somewhere in this trail? So when we're done, we're going to return if this counter has reached 3 or gone beyond it. Okay, and again, it was inclusive in this one as well. All right, so we need to consider every trail switch. We're going to be looking at successive markers. So if we did something like this, where we went across the entire array, depending how we write the next piece of our code, good chance we go out of bounds. So if you want to go to I plus 1, then you have to roll back your stopping rule by 1. If you want to go to I minus 1, then you need to roll back here by 1. Okay, and so if, and this is where I'm going to use my absolute value, okay, I'm going to say markers at I minus 1, okay, minus markers at I'm going to step out of the absolute value. Okay. If that is exceeding or equal to 30, then I'm going to count that as one of my difficult switches. All right. If we didn't use absolute value here, we'd have to write like two different cases. Okay, so greater than or equal to positive 30, less than or equal to negative 30. Again, I started the loop at 1 to allow me to look one marker to the left without going out of bounds. Okay? If I did I versus I plus 1, I'd start the loop at 0, and I'd put in either a plus 1 on the left or a minus 1 on the right of this inequality. All right, and again, I'm looking for that count variable to exceed or equal 3. It'll be labeled difficult at that point. All right, so I just gave it a couple of test cases, but it looks like they're working, and you could add some more. So yeah, I mean, 2010, easy year, but I guess then the curve works out a little differently. All right, so if you don't know, now you